In this video, I'm going to look at two questions on the topic of circuits. So, first of all, we have determined the current in the 6 ohm resistor in figure 1. The cells have no internal resistance. So over here we have a diagram. The 6 ohm resistor is over here, so what you want to calculate is current flowing through it. In this case, the circuit looks like a parallel one, however there's two batteries. So in this case, I suppose we need to utilize Kirchhoff's law to do this. So what we know is that Kirchhoff's second law states that the sum of all the EMFs is equal to the sum of the potential differences. So let's say I'm going to, because we want to calculate the current through the 6 ohm resistor, so I'm going to choose these two circuits to try to derive an equation. So this is the first one and this is the second one. Now, so first what we have is 9 volts for the EMF is equal to, over here I have to label the direction of current. So basically this direction current is this way, so therefore I suppose it will look something like this. Okay, so in this case, both the currents through the resistors are aligned with the direction of current in the circuit, or the conventional one, so therefore both of them are positive. Now in this case we would say 4 for its resistance times by the current will be equal to the voltage, or the potential difference in this case. So I'm going to say the current will be I4 and then plus 6I6. And for the second equation we have is 9 plus this, which is 15. And then, so this will be 9I9 plus 6I6. And then I mentioned Kirchhoff's law, so this is Kirchhoff's second law, there's still Kirchhoff's first law, and in this case it might be quite useful. So it basically says at a certain junction the current going in is equal to the current going out. So I suppose I'm going to utilize this junction over here. So what we have is the current going in is I4 and then plus I9, and the current going out is I6. So now we have three equations over here, and what we want to calculate is I6. Okay, so my idea is this: I'm going to utilize the last equation for the last step. So let's see from the first equation. From the first equation, I'm going to isolate I4. Okay, so I4 it will be equal to 9 minus I over here over 4, and then from the second equation, I9 is equal to 15 minus 6I6 over 9. And we are going to substitute this into the third equation. So what I'm going to do is multiply both sides by 36 in order to cancel out the denominator. So for I4, it's times by 9, so therefore that will be equal to 81 minus 54 I6, and then plus times 4, which is 60 minus 24 I6 is equal to 36 I6, and then we can solve for I6. So over here, 36 plus 24 plus this is 78, and that will be 114. And then this is equal to 141. So therefore, I6 will be equal to 141 over 114. And I'm not going to convert it into decimal. So over here we have the answer, so in amperes. Now let's look at the second question. Over here it says a chain of resistors figure 2 is composed of n units, each consisting of 3 resistors, each resistor of resistance R. So all of the resistors are identical, figure 3, okay. And then a unit is attached to the left hand end of the chain in order to increase the number of units from n to n plus 1. And then the question wants us to calculate the resistance between A and B across a chain with 2 units, R2 and the resistance R3 across a chain with 3 units. Okay, so there's 2 questions in this component. First of all, I suppose I'm going to draw a diagram first for some kind of visual illustration. So this is one unit, and then the second unit will be connected like this. So all of these resistors are identical with resistance R. So, okay. I'm going to look at this circuit in this way. So from A to B, there's 3 major components in series. So this is the first part, this is the second part, and then this is the third part. And within the second part, these 3 are in series, which are parallel with this one. Okay, so over here, I'm first going to calculate the resistance of the second part. So 1 over R, let's say R2, R2 will be equal to 1 over 3R plus 1 over R. So 1 over R2 will be equal to 3 over denominator, that is this, so therefore R2 will be equal to 4 over 3R. And then, so therefore, oh, it's R2 as well. Okay, I'm going to add this to differentiate, so therefore R2 will be equal to 4 over 3R plus 2R, or the 2 resistors in series. And what we will get is 10 over 3R. And that will be one of the answers. And then it says across the chain with 3 units. So if we add another unit, see, I'm not going to recalculate this entire thing. So let's see. Okay, so my idea is that we can look at in this way. So I'm going to add the circuit over here. Now in this case, it should be a lot easier. So we already know the resistance of this part, and we only have to calculate the resistance of this entire part in parallel with this and then add another 2. Okay, so in this case, this will be see, 1 over R2 is equal to this is one part, and the other part is just one of the R's. So therefore, will be equal to, this is basically 3 over 10, so therefore that will be 3 plus 10. Yeah, so therefore it's 13, 10R. And the resistance of this part will be 10 over 13R. And therefore R3 will be equal to 10 over 13R plus 2R. And this will be equal to 36 over 13R. And this will be the answer. Now let's see the second component. So over here it says a unit is attached to a long chain. The resistance of the chain RT is not altered by this addition. And then it wants us to determine the resistance of the chain. Okay, so I suppose we can assume that this chain is infinitely long, and then it reaches a point where if you add another unit, the resistance will change. And yeah, I think so. So how do we do this? From the question, what it says is that the resistance of chain RT is not altered by this addition. So, okay. Let's look at this diagram first. So my idea is that it says RT. So, okay, so this is my idea. Over here, it's given us that this part is RT, right? And then it adds another unit over here, and RT doesn't change. So, okay. So, so if we were to say RT is equal to the resistance of this entire thing, is also RT, then we will be able to establish an equation. So over here we will say RT is equal to, no, I'm not going to write it like this. So it will be 1 over RT will be equal to, because essentially in this case it's actually two circuits in parallel. So over here what we have is 1 over RT plus 1 over 3R. No, I don't think it's like this. It's the same idea with this one over here. So we can look at it this way. We can break it into this part, and this part. Yeah, and then this part has a resistance of RT. Okay, so will be equal to 2R plus 1 over R plus 1 over RT. Yeah, and then let's calculate this. Okay, so I'm first going to simplify this. So over here, RT, so therefore numerator must be RT. Now there will be R plus RT. So then, let's see, RT minus 2R times R plus RT is equal to RT. And then we want to isolate RT. Yeah, so I'm going to expand the brackets over here. So RT plus RT squared minus 2R squared minus 2R RT. And this cancels out. What's left will be RT squared minus 2R RT minus 2R squared. Notice how I actually made this into a quadratic equation, and the variable is RT. So this is somehow a quadratic equation, so therefore we I don't think factorizing will actually work. Yeah, so let's utilize the quadratic equation. So therefore RT is equal to 2R plus or minus. However, resistance cannot be negative, so therefore only plus, and 4R squared. And then minus 4AC, which is plus 8R squared over 2. So RT is equal to 2R plus, this is 12R squared, the square root of 12R squared. Now that we can factorize out 4, so therefore it will be 2R, we can factorize out 2R, and then square root of 3 over 2. So therefore RT will be equal to, the 2's cancel out, and what's left will be R, we can factorize R out, and then what's left inside will be 1 plus the square root of 3. And this will be the answer to the question.